Oh boy, now we're going to start two-column proofs. So this is when we really get into the meat of the business of doing proofs in geometry. And starting out with the algebraic proofs are really the best way for you to get your feet wet because they're things that you understand how to do. Basically, it's just going to be learning how to write them out as two-column proofs. So a two-column proof is just how we organize our thinking. It's very common in geometry to use a two-column proof. There's also paragraph proofs, but we probably won't get into those very often. So a two-column proof has a left side and a right side, and the left side is used for statements. All right. And we've done a lot of statements lately, right? And the right side is used for reasons. And there's very specific things. What can be used as reasons? The only things we can use are properties, definitions, postulates, and theorems. So for right now, we're just dealing with algebra, which will be fine, right? So a two-column proof always starts out with something called a given. They're going to ask you, they're going to give you a statement, and they're going to ask you to prove an outcome or a conclusion. Okay. So given this particular statement, they want you to get to this. So for the first one, the statements, the first statement is usually going to be the given, whatever they gave you. So this is a divided by -6 plus 2 equals 5. Now, the reason that goes on the side, the reason is given. That's our number one reason that we use, okay? They gave you that statement. That's where you start. It's like the starting point. And you can always start your proof with what they gave you. You don't always have to start it there, but you can always start it there. Now, if I was going to solve this particular equation, what would I do first? Well, I would probably deal with that 2. So how do I deal with that 2? I subtract it from both sides, right? So I would be left with a divided by -6 equals 3. And the reason that we're going to put in there, the property of equality that we're going to use is the subtraction property of equality. And yes, you have to write it out. I'll let you do the equal at the end, okay? Now remember, we can only use properties of equality if there's an equal sign, so that's fine. Now, how do I get to A being by itself? Well, I have to get rid of divided by -6. How do I do that? I multiply both sides by -6. And that will leave me with, just do a quick erase here. I want the colors to be the right ones. So this would be A equals -18. Hey, look, it's exactly what we were supposed to get. Now, how did I get there? I used that multiplication property of equality. And we're done. We've done what they've asked us to do. They gave us a statement and we ended with the right conclusion. All right. If you didn't get -18 at the end, you should probably go check your math. Okay. Let's look at this one. So the next one, again, starts with a given statement. Now, what is the given statement? It says 6x plus 7 equals 8x minus 17. And once again, our reason is because they gave it to us. So it's given. All right. So I'm going to go over here. What am I going to do next? Well, I like to get my variables on one side. So I'm going to subtract 6x from both sides. And that's going to leave me with 7 equals 2x minus 17. I had to subtract, so that's going to be my property, the subtraction property of quality. All right, what's my next step going to be? Well, I need to get my 17 away from my x. So I'm going to add 17 to both sides. So that means 17 plus 7, that's 24, equals 2x. And I had to add the 17. So that is the reason, the addition property of equality. All right, next steps here. Well, it looks like I could divide to get the x by itself, and if I divide by 2, I get 12 equals x. And that is the division property of equality. But I notice it doesn't say x equals, so we are going to use that, what's that property again? The symmetric property. It says that I can just flip it around, okay? So we wanted to prove x equals 12, so it needs to be in x equals 12 order. So this is the symmetric property. So those aren't too bad, right? Stuff you know how to do on the left side, new stuff on the right side. So let's look at these next two. So once again, they've given me an equation, and they've also given me what I need to prove. So I'm going to start with my given, which is negative 9 times the quantity 2x minus 3 is equal to 63. That is given. So to solve this equation, I need to do that distribution first. So I'm going to do negative 18x plus 27 equals 63. And that is that distributive property of quality. Still looking to get x by itself, so I'm going to subtract 27 from both sides, so I get negative 18x equals 36. And that is the subtraction property, because I had to subtract the 27. And I still need to get x by itself, so I need to get rid of that negative 18. I'm going to do it by division. All right. X equals negative 2. That's what we were supposed to do. That's perfect. That's what we were supposed to prove. And this was that division property of equality. All right, save the best for last. This is a big one. Look at this one. 6 lines on this one. We can do it in 6 lines totally. So they've given us this rather long equation that we need to solve, and we need to prove that x is equal to 1.5. So let's start with our given. Negative 7 times x plus 2 plus 4x equals 6 times the quantity 2x minus 4. So as usual, our first is going to be given. Just write that down because that's where we're going to start, right? And the next thing we know what we need to do is there I have 2 places where I have to distribute. So I'm going to do that all in one step. Negative 7x minus 14 plus 4x equals 12x minus, almost said 4, but it should be 24. Now, that property that we did, all we did was distribute. So that's what we're going to write here, the distributive property of equality. All right. It's looking a little sloppy here. So I am going to combine like terms, but that's also called simplification. So that's actually the step that we're going to take here. So I'm going to say negative 7 and positive 4x, that's negative 3x minus 14 is equal to 12x minus 24. And that is just simplifying. Okay. Now we can, I'm going to get my variables on one side. I'm going to subtract 12x to get negative 15x minus 14 is equal to negative 24. And we use that subtraction property of equality. Now I need to get rid of the 14. So I'm going to say negative 15x. I'm going to add 14 to both sides is equal to negative 10. So adding 14 means I'm going to use the addition property of equality. And now I have one more step to go. I have to divide both sides by negative 15. So I'll put x equals 1.5. That's exactly what we were supposed to prove, and I did it with the last step being the division property. Okay.